Assalamualaikum. In this video, our group will present about vacuum forming, including what is vacuum forming, the process involved in vacuum forming, the raw materials used, the parameters and its application. So what is vacuum forming? Vacuum forming is one of the manufacturing process to produce the plastic products. So as we can see in the video, the process initiates with the heating thermoplastic until it becomes pliable, and then it was stretched over the mold and the vacuum was applied to remove the air between the mold and the sheet. There are three main steps to produce a plastic using vacuum forming, including heating, forming, cooling and demolding. So the detail will be explained later. Common material used in vacuum forming process is ABS because its properties and it has excellent formability, easily to trim and has various of grades. So why most of the manufacturers use vacuum forming is because they can lower the production cost, and it is suitable for large scale production of simpler components like plastic cups.
So now let's talk about the process of vacuum forming. Vacuum forming can be divided into 5 parts. And now let's talk about the first part, which is heating. So firstly, a thermoplastic sheet is clamped securely into a spreadsheet frame, and then the thermoplastic is heated until the optimal forming temperature is reached. This causes the thermoplastic to become soft, shapeable but not melted completely. Next up is the molding. So compressed air is blasted to stretch the plastic before the molding process. This process is known as pre-stretching. The mold is then pressed onto the soft plastic. Next up is the vacuuming process. So a powerful vacuum removes all the trapped air between the plastic and the mold. So this is where the product starts to form. Moving on to the fourth part of the process, which is cooling. So a large cooling system or a misting system are used to cool down the plastic. The process is done to let the plastic regain its rigid state, and once cooled, air is blasted to remove the product from the mold. And lastly is trimming, or as known as finishing. So the process is the product goes to the trimming process. By using machines such as saws and die cutters, the excess plastic from the product are removed, and the outer edges will be removed as well. Then the scraps of the excess plastic will be recycled and reused for further projects. Okay, that's all.
For raw material, this process needs material that can primarily relies on rapidly softened by heating and hardened by cooling. So as we know, the polymer we have three types, which is thermoplastic, thermosetting and elastomer. So the most suitable material that we use in this process is thermoplastic. So thermoplastic is the most common use. This material melt when heated and retain their shape when cooled. So for example, we have ABS, acrylonitrile, butadiene styrene, polyvinyl chloride, PVC, and acrylic PMMA. And next, the thermosetting. This polymer we rarely use because this polymer undergo a chemical change when we heat it and cross-link permanently. So because of this, the material will burn rather than soften upon reheating. And lastly, elastomer. This material is flexible. We can use if highly flexible or rubbery and product required. So this material required a specific handling to maintain the shape.
Explain about key processing parameters. Firstly, temperature. Temperature controls the softening and flexibility of the plastic sheets. The sheet must be heated to a suitable temperature so it can be easily formed over the mold. If the temperature is too low, the plastic may not form properly and fine details may not be reproduced accurately. However, if the temperature is too high, it can cause sagging, excessive thinning, and also material degradation. Second, pressure. In vacuum forming, vacuum pressure pulls the heated sheet tightly against the mold surface. This parameter affects how accurately the sheet conforms to the mold sheet. Higher pressure generally improves dimensional accuracy and surface detail. On the other hand, insufficient pressure can cause in wrinkles, air pockets, or incomplete forming. Next, heating and cooling time. Adequate heating time ensure that the plastic sheet reaches a uniform forming temperature, preventing uneven softening and defect. After forming, sufficient cooling time is required for the product to solidify and maintain its shapes. If cooling is insufficient, the final product may experience wrapping, shrinkage, or deformation.
Next is forming speed. Refer to the rate at which the heated sheet is shaped over the mold. This parameter plays an important role in determining how accurately the shape conforms to the mold surface before it cools and solidifies. Faster forming can improve production efficiency and detail reproduction. However, if the forming speed is too slow, the shape may cool prematurely, resulting in incomplete forming and reduced product quality. Next, material types. Different thermoplastic require different forming temperature and processing condition. The properties of each material such as flexibility, strength, transparency, and heat resistance significantly influence its performance during forming and the final application. Therefore, the selection of material types play a crucial role in determining the quality, appearance, durability, and functional of the final product. And lastly, sheet thickness. It can affect the strength, rigidity, and durability of the final product. Thicker sheets generally require high temperature and longer heating times. Thinner sheets are easier to form but may produce weaker products.
So for the next slide, I will explain about the applications of vacuum forming. So first and foremost, I will explain about food packaging. So first, vacuum forming is widely used in food packaging to produce food trays, clamshell containers, and blister packs. The process creates packaging that is lightweight, transparent, and cost-effective, making it suitable for protecting and displaying food products. So secondly, it is also used in the production of acrylic bathtubs. Heated acrylic sheets are formed into the desired shape, resulting in a smooth surface finish while allowing large products to be manufactured efficiently. So thirdly, in the automotive industry, vacuum forming is also used to make dashboard panels and interior trim components. These parts are very lightweight, which helps to reduce vehicle weight and improve fuel efficiency. The process can also produce complex shapes at a very low cost. And lastly, vacuum forming is also used to manufacture medical trays for surgical instruments and medical devices. This trays helps to protect the equipment during storage, transportation, and sterilization.
In conclusion, vacuum forming is a widely used thermoforming process that shapes heated thermoplastic sheets into specific product. The process is cost-effective and suits for larger production in industries such as automotive, medical, food packaging, and consumer goods. The quality of product depends on key processing parameters including temperature, cooling or heating, time, pressure, forming speed, sheet thickness, and material type. Overall, vacuum forming offers a practical solution for producing high-quality product with low cost.